Hello everyone, welcome to section 8. We will now cover how to tell if repeatability of a measurement system is acceptable. On the previous sections, we discussed the bias rule. We want a system whose bias is less than 15% of the process tolerance. Remember that calculations are done based on only one side of the tolerance. If the part has a tolerance of 5 inches plus minus 1 inch, we do the calculation on the upper or lower limit, so it's still 1 inch. We do not do the calculation on the complete tolerance, which in this example would be 2 inches. If you have questions on this, please review the previous topics. Now, for the standard deviation of the process, we do not want the width of the 3 standard deviations to exceed 20% of the process tolerance. We would write it as is: 3 sigma needs to be less than or equal to 20% of the complete process tolerance. Note, just like before, the 20% overall process tolerance for repeatability formula is a general use recommendation from Kusum Academy based on professional experience and not a regulatory or international standard requirement. If you decide to document it as part of your MSA corporate validation procedure, then you will have to meet it, but it is not a regulatory standard requirement. It's just a best practice that we're recommending to our students. So let's do an example here. Let's say that we have a system, okay? And this system will be used to measure parts that need to be 10 grams plus minus 2 grams. So that is an overall tolerance, right? Now from here, as you can see, the sample, golden sample, is only 5 grams. It is not 10 grams, okay? Now I'm gonna take this information, I'm gonna paste it over into Minitab, and I'm going to determine if the system is biased or not. So I'll select C3, and I'll select a hypothesized mean of 5, and then we'll see our output. By this point, everyone should be familiar with whether there is bias or there is no bias. So I will take a second right now. Please write down your answer. Okay, so the system is not biased. The p-value is above 0.05. If you are not familiar with this topic, please review the previous sections where we cover bias in depth. Now, we know that the system is not actually biased, okay? And now we need to calculate the standard deviation. So we can simply do stat basic display. We'll take our C3 column and we get our standard deviation of 0.0096, which is showcased here. Now, is this a problem or not? Well, we're simply gonna do our rule. 3 sigma needs to be less than or equal to 20% of the tolerance. 20% of the tolerance is 2 grams. So here, we typed in inches. Let's call this grams. There we go. That's a lot better. And let's call this 1 grams as well. Apologies for that. We'll make sure the file that you receive does not include those typos. So 3 times 0.0096 needs to be less than 20% of 2 grams. After doing the calculations as shown here, we get that this overall process is eating up 1.44% of the overall tolerance. Since this 1.44% is less than 20%, we accept the system. Okay? Now this was as simple as simply doing 3 times 0.0096, which is 0.0288, and then we simply divide it by 2. We're dividing it by 2 because that is the overall tolerance. So we have 0.01. This gets multiplied by 100 to turn it into a percentage, and we get 1.44%. Since 1.44% is less than 20%, then the system should be acceptable for our uses. Visually, it looks something like this. If I give the system a sample that is 10 grams, the system might report it as 10.01, 999, 998, 997, 10.02, 10.03, etc. But at no point am I running the risk of rejecting a good part and identifying it as a bad part. Here is how it would look visually with the spec limits added to it. The smallest a sample can measure is 8 grams, and the heaviest is 12 grams. At no point is a 10-gram sample running the risk of being miscategorized as a bad part because it's too heavy, or as another bad part because it is too light. So we're now going to do a second scenario. So let's say we have a manual measurement. The results of measuring an 8-inch gauge block are summarized below. We want to use this system to measure parts with a tolerance of 8 inches plus minus 0.05 inches. Does this system meet our repeatability rule? So I'm simply going to copy my information. I'm going to paste it over here into Minitab. There we go. And we're going to do stat basic and then display. We're going to grab C3. And we have here our mean and our standard deviation. The standard deviation right now is 0.025. 3 times sigma would be 3 times 0.025. I can do the calculation here. That would be 0.075. 0.075 divided by the tolerance of 0.05 needs to be less than or equal to 20%. In this particular scenario, I can immediately see that it will not fit. It's actually 1.5, which multiplied by 100 is 150%. So 150% is not less than or equal to 20%. So this fails. The system has too much variation to properly measure a sample with a tolerance of plus minus 0.05. Now, we can see this visually like this. If I give my system a part that measures exactly 8 inches long, this particular example states that my test method might say that the part is 8.02, 8.04, 8.06, 8.08, 7.98, 7.96, 7.94. And we're not talking about part-to-part manufacturing variation, as you might get when you're executing or creating parts. We're simply talking about my inspector when he measures in the morning, midday, at night, the exact same sample. He's not going to be sure about the result. If I consider the actual tolerances in this range, the maximum that the sample can measure is 8.05. And the smallest it can measure is 7.95. So while my inspector might say, oh, sample is within range, 7.98, as soon as I tell that to manufacturing, they're going to try and adjust the process to get it into nominal. And by doing so, they're going to push the curve, right? And then my inspector might grab a next part and say, oh, you know what? It's still light, 7.96 or 7.955, for example. So we're doing overcorrections. And then I just store that sample. I don't tell anyone. And I give my inspector that sample back in 2 or 3 hours. And then all of a sudden he's going to say, oh, you went too far. It's now too heavy. It's now too big. But it's the exact same part he told me was small a couple of hours back. It's not that the part is growing or shrinking with time. It's that my tolerance is too small when compared to how repeatable my measurement system actually is. So as we show here, if we keep this system in place, we run the risk of saying that the same part measured in the morning is small. We might say it's below 795. And then if we wait a couple of minutes and measure it again, we would say the part is big, above 8.05. And this dance would continue for days and days and days. The system is simply not capable of detecting good parts and bad parts with such a small tolerance. Now, does this mean that we need to scrap the system? Do I need to throw out my CMM machine? No. We simply need to identify for what this system is actually useful for. Let's say I want to use the same system that I do not want to use previously because it can't meet the specificity, and I want to use it now for a tolerance of 15 inches plus minus 2 inches. The tolerance is now a lot bigger. The standard deviation of my system does not change. I'm still doing 3 sigma, with sigma being equal to 0.025. So 3 times sigma still equals 0.075. But now I'm dividing it by 2 inches. This system eats up 3.75% of the overall tolerance, and as such is adequate for measuring samples that are between plus minus 2 inches in tolerance. Visually, it will look something like this. A part that is 15 inches, the lower spec is 13, upper spec is 17. We do not run any risk of miscategorizing the part. What is the main objective of this lesson? We need to understand that not just because something failed or passed doesn't mean that it is useful or useless. We must, as engineers, find the use for our equipment. So I can have the best test method in the world, right? But if my tolerance is very small, it might still not be good enough. However, that does not mean that I need to throw the system out. I simply need to use it for other parts that have bigger or wider tolerances.